What's good, YouTube? It's Mr. A, aka Almond with the Sauce. And in today's Algebra 1 video, I'm gonna be going over linear equations in slope-intercept form. I'm gonna teach you how to go from the graph to the equation, how to go from the equation to the graph, as well as some examples. So get your pencil, get your paper, and let's get into it. All right, so check this out, man. Let's say, you know what I'm saying, you're in high school or whatever, and you know, your report cards come in, your mom and your dad, they look at your grades and they're good, you know what I'm saying? You're doing your work in school, you're behaving right, and so they decide to bless you, you know what I'm saying? They finally gonna get you that game that you finally wanted. They're gonna cop you that PS4, bro. They're gonna get it for you, you know what I'm saying? So you over there lit, you know what I'm saying? Like, yes, I'm finally gonna get on the game, get to play with my homeboys or whatever, you know what I'm saying? But, you know, if your mom's anything like my mom, you know, she old school, you know what I'm saying? Like, in her mind, you just buy the game and play the game and that's it, you know what I'm saying? But little does she know, you know what? You gotta get the PlayStation Plus, you feel what I'm saying? Like, you gotta play online, no point in playing the game by yourself. So you gotta buy that PlayStation Plus, you know what I'm saying? So you get your allowance or whatever, and your parents are like, all right, we're gonna get you the game, but you gotta pay for the PlayStation Plus on your own. And so you're like, all right, bet. Let's say you get a $50 allowance, let's say. So every month, you're gonna have to pay on your own for that PlayStation Plus. And so that's cool, you know what I'm saying? So, cause if you look it up, it's like what, $10 a month for the PlayStation Plus. So that's cool, we can do that. So let's say in this example, we're trying to look at how much money we're spending over time. You know what I'm saying? Like 2 months down the road, a half a year down the road, 2 years down the road. How much money are we really spending? So let's look at that. All right, so what we're trying to do is basically look at how much money we're spending down the road, you know what I'm saying? Like 2 months into having our game, how much have we spent? A half a year down the road, how much have we spent? 2 years later even, we can look and see how much money have we really spent on this game. So one way we can do that is to, you know, look at a chart or like a table. So in one column, we can say like the number of months or how long it's been. And then we're gonna look and see, you know, the total price or how much money we've really spent depending on how long it's been. Day one, before you even start considering PlayStation Plus, we gotta buy the game in the first place, right? So let's say no time has even gone by. 0 months have gone by, and you know, your parents, you know, like they said, they're gonna buy the game for you. So let's say you find like a little bundle deal or whatever, and it's $200 for the game and the console. So, you know, we haven't even started considering months yet, but we paid $200 so far. All right, now 1 month in, the agreement was you're gonna pay for PlayStation Plus by yourself, and that's cool because it's just $10 a month, right? So 1 month into having the game, you spent what? $210 was your total price, because you know, $200 for the console and then $10 for the PlayStation Plus. And we can keep going if we want to, you know, 2 months in, that's another $10, you know what I'm saying? So it's really just gonna be $220 total so far that you spent. And you know, you already know the pattern. Each month, what happens? Another $10. So now we're gonna be looking at $230. So that's one way you can, you know, kind of look and see how much you spent depending on how long it's been. Problem is, what if we wanted to look and see, like, you know, 2 years down the road, how much have we spent? Now you could, you know, do 4, 5, 6, all the way to 24 months, but who has time for that? You know what I'm saying?
Ain't nobody got time for that.
What I think we should do is let's try to come up with an equation that's gonna help us figure out how much money we've spent depending on how long it's been. If we're trying to look at an equation, right? We're trying to figure out our total price, or how much money have we spent depending on how long it's been. So you already know, like we said, the PlayStation Plus is $10 for every month. So you know, if it's 1 month, that's $10. If it's 2 months, it's $20. 3 months, $30, etc. So really it's just $10 times the number of months that we've been playing. So I can say 10 times the number of months that it's been. But remember, we had to buy the game in the first place, so we got to tack on that extra 200. And that's basically it. that's how we can figure out how much we've spent. So, you know, if it's, let's do an example. Let's say, you know, we've spent 2 years on the game, and you're wondering, you know, how much money have I really spent in 2 years of playing this PlayStation? So we can just use our formula that we made, which is 10, and then if it's 2 years, what's that? 24 months plus 200. And I'll let you figure out what that is, but that's how we can figure out how much we've spent. All right, so another way we can look at how much we spent instead of using an equation is just look at a graph. That way we can just look at it and see. So let's just plot the points, you know what I'm saying? Like at 0 months, like we said, before we even started getting PlayStation Plus, we got the game, you know what I'm saying, which was $200. And then just like the equation said, 1 month in, it added $10. So, and then 2 months in, add another $10. 3 months in, another $10. And by now, y'all should already be looking at the pattern. What happens after each month? It adds another $10. So if you look at the dots and when we connect them, you'll notice, what does it make? A straight line. Hence the term linear equation. So that's basically how linear equation works. Like you have some value that you start at, your initial value, which in this case is 200, and then you have what's called a rate of change. And basically what that means is it's like a rate of change. At what rate is my price changing? Well, it's changing at a rate of $10 for every 1 month of time that goes by. So looking back at the equation, we have our price and our number of months. Those are our two variables, right? X and Y. So now, like y'all know, you have the independent variable and the dependent variable. How do you know which one is which? Well, which one depends on the other? Well, as you can see, the price depends on what? It depends on how many months we've been playing the game. So since the price is doing the depending, we say that the price is our Y, or our dependent variable, because it depends on the number of months. And then our number of months is going to be our independent variable, or our X. So looking at this equation, we have Y is going to be equal to 10 times our number of months, which we said was X. And then again, plus that initial 200 that we dropped on the game. So looking at the graph, you can easily go from equation to graph by plotting that initial value right here, that 200. Before we even start considering months, we know that that 200 is going to be on our y-axis, right? And there's a name for that. We call that the y-intercept. And that basically means wherever our line touches the y-axis, that's our y-intercept. And then additionally, we have, you know, the rate of change. And what we call that sometimes is the slope. And the reason it's called the slope is because that rate of change can determine, you know, how tilted our line is. So for example, let's say Sony wanted to charge $15 a month instead of 10. How would our line change? Well, you know, we still pay the $200 for the game, but then every month, instead of going up $10, we go up $15. So our point would be, you know, somewhere right here. And then another month will go by, another $15. Another month, another $15. So if you look, if I were to keep doing it, you know, my line would be more steeper than the yellow line. So that's why we call it the slope, because that $10 a month, or that rate of change, determines how slanted our line is. All right, so in general, your equation for a line is going to look like this. You're going to have your y equals, now your slope or your rate of change, we usually refer that as the variable m. So the m just means the slope. And then you have your x, which is your independent variable, and then your y-intercept is going to be b. So in this case, our b is our 200, and then our slope or our rate of change is our 10. And so basically when you go to graph it, you just plot your b, whatever number b is, you just put that on your y-axis. And then your slope or your rate of change is going to be how you determine your next point. So in our case, our slope was 10 per month. So for every 1 month, we went up $10. Another month, another $10. Another month, another $10. And one thing to note is that the reason it makes a straight line is because every month you're adding the same $10 every single time. Y'all know the word constant means just the same thing over and over again. Every single time we go a month, we go up that same $10. So that's kind of why, it makes that straight line, because as we go over, we go up the same amount. Also, one thing to mention is that, our 10 is our slope, right? And that 10 refers to, every month our price goes up $10. So it's really $10 for every 1 month of time that passes by. And the slope is important because there's two parts to the slope. There's the change in y, or the rise, and then the change in x, or the run. All right, so let's look at this m, or this slope, real quick. I want to talk about what that slope means. So your slope, or m, is really just the change in y, or our change in price per change in x. And what we usually say is the change in y is called the rise, because your rise goes up and down just like the y. And then the change in x, we usually refer that to the run, because when you run, you go left and right, you're changing x. So your rise divided by your run, that's going to give you your slope. All right, so in this first example on how to graph linear equations, we have y equals 2x plus 3. And so what I suggest is to start out by plotting your y-intercept, or your b value. In this case, it's positive 3. And remember, the y-intercept is the point where it crosses the y-axis. So I'm just going to go from my origin. I'm going to go up 1, 2, 3 and plot my first point. And then the way I get more points is I have to use my slope, which in this case is 2, or you can think of it as 2 over 1 if you want to do rise over run. And so what you do is not from the origin, but from this first point, I'm going to use my slope of 2 to get my next point. So I'm going to go up 2, which is my rise, and then to the right 1, which is my run. And then I could stop right there if I wanted to, but for the sake of this example, I'm going to do more. All I got to do is do the same thing. Remember that constant rate of change, up 2 to the right 1. And if I wanted to, I could do the opposite. Instead of going up 2 and to the right 1, I can go down 2 and to the left 1, down 2 and to the left 1. And once you have enough points, from there, all you got to do is connect them, and that's how you make your line. All right, so in this next example, we got y equals negative 2/3 x minus 4. So the steps are the same. You're going to start by plotting your y-intercept. This time, be careful. Last time it was a plus, but because it's a minus, we're going to go down 4 to plot our y-intercept. And that was our first point. Now to get more points, again, we use our slope. This time our rise is going to be, because of this negative sign right here, our rise is actually going to be -2, and then our run is going to be +3. So that means we're going to be going down 2 and to the right 3. So down 2 and to the right 3. Down 2 and to the right 3. Now, just like last time, you can do the opposite if you want to go the other way. Instead of going down 2, we can go up 2. And then instead of going to the right 3, we can go to the left 3. And we just plot a whole bunch of points. Now, again, we only need to plot 2 points to make a straight line. But just for, the sake of example, I'm going to show you how to do a whole bunch of points. So up 2 to the left 3. Up 2 to the left 3. All right, now you can already see what the line is going to look like, but in order to actually graph it, you got to make the line. And so that's it. All right, for this next example, we're going to do something a little bit different, a little bit more involved. There is some algebra to it. Now we're trying to graph the equation 2x minus y equals 3. Now straight off rip, you already know it doesn't look like y equals mx plus b like we want. So what we got to do is we got to use a little bit of algebra to get y by itself, and then we can graph it. So what I'm going to do, since this y is already negative, is I'm going to go ahead and add a y to both sides, and you'll see why I'm doing this in a second. So you already know the y's are going to cancel out, and then I'm just going to bring down my 2x. Alright, and then the next thing I want to do to get y by itself is I'm going to subtract 3 from both sides. And then these 3's cancel out, so now y is by itself. But be careful over here. A lot of people want to say like 2x minus 3 is negative 1x, but you got to be careful because they're not like terms, so you can't combine them. So the only thing you can do is just say 2x minus 3. And just so it looks like what we're used to, we can go ahead and flip it and make it y equals 2x minus 3. And you know, the graphing is the same. Go ahead and plot your y-intercept of -3. And then if you want, a lot of people like to explicitly define their rise and their run. So after you do your y-intercept, you're going to go up 2 and to the right 1, up 2 and to the right 1, and keep going. And that's all you got to do. All right, so in this last example, this one is a little bit more involved than the last one. Same concept though, we want to get y by itself, so we got to do a little bit of algebra. Now this time I noticed that this 3x term is being added, so I'm going to do the opposite and subtract 3x from both sides. And then those are gone, so I'm just going to bring down my -1/2 y. And I'm going to say equals. Now again, these aren't like terms, so we can't combine them. But here's where we got to be careful. You know how it's y equals something x plus b? I'm going to put the something x first so that it looks like what we're used to. So I'm going to say -3x, and then I'm going to add on this 2. And the reason I'm saying plus 2 is because it's positive. If this was a -2, I would have said -2. Alright, now here's the most trickiest part. We want to get y by itself, right? And so what we got to do is we got to somehow get rid of this -1/2. And so to do that, what I'm going to do is I'm going to multiply both sides by the reciprocal, and all reciprocal means is just flip the fraction. And so I'm going to multiply by -2/1 on both sides of the equation. And when I do it on the right, I'm doing it on the entire right side. So -2/1. And the reason we do that is if we multiply both of these, I can get a 2 times 1, which is 2 on top, and then a 1 times 2, which is a 2 on bottom. And you know negative times negative is a positive. So those are going to cancel out, and then I'm going to be left with y by itself, which is what I want. Now I'm going to distribute this, and you can think of it as a -2. I'm going to distribute this, and so I'm going to get -2 times -3x, which is a positive 6x. And then -2 times +2 is -4. So the way you graph it is the same as the other one, so I won't actually graph it, but once it looks like this, now you're good to graph it. So it was just a little bit of algebra that we had to do to get it in a form to where we knew how to graph it. Alright, so real quick, I wanted to show y'all how to go from the graph to the equation. And it's kind of the same concept. You know, you're looking to see where your y-intercept is, and then you know they use the slope to get the next point. So here's how you do it. The first part is easy. You know it's going to be y equals something x, and then plus or minus b, right? Your b being your y-intercept. So all you got to do is look and see where it crosses the y-axis. In this case, it's at -4. So you know my y-intercept is going to be -4. And then all you got to do is figure out what is your slope. So you can see how as we go to the right, our line is going upwards. So that means our slope is going to be positive. And all you got to do is just figure out your rise, which to get from one point to the next point, our rise is how much vertically they moved. So as you can see, we went up 2. So our rise is going to be 2 over our run, which is how many spaces side to side it went to get from this point to this point. And so you just got to count 1, 2, 3, 4, and 5. And so our run was 5. And that's all you got to do. So our equation for this line is y equals 2/5 x minus 4. And that's all you got to do. Thank y'all for watching the video. Hopefully it helped. If it did, make sure you leave me a thumbs up. If you have any questions or suggestions as to what I should make in the future, make sure you drop a comment below. Make sure to hit that subscribe button if you're new. And with that being said, I'm out.